In section 6.8, we're going to talk about trigonometric inverses and their graphs. However, we're not going to focus so much on their graphs. We're really going to just worry about what kind of answers we get for trigonometric inverses in the graphing calculator. So our book uses a symbol called arc sine. That's because our book is a little old. It's really just the same as inverse sine. Arc cosine is going to be the same thing as inverse sine or inverse cosine. And arc tangent is going to be the same thing as inverse tangent. Now what I want to talk about right now is when you do an inverse sine, cosine, or tangent in the graphing calculator, you get answers in a specific range. We're going to call those principal values. So the graphing calculator is only going to give you answers for inverse sine or inverse tangent between negative 90 degrees and 90 degrees, or negative pi over 2 and pi over 2. We've already run across this when we've done inverse sines, when we did the law of sines, and we would solve an equation for an angle. We would always get an angle between 0 and 90 because the law of sines, when we're talking about triangles, isn't going to give us a negative angle. But inverse sines and inverse tangents always give you angles between negative 90 and positive 90. That means the answers are always in quadrant 1 or 4. Inverse cosines, however, in the graphing calculator, will give you an answer between 0 and 180 degrees. Oops, let's make that look a little nicer. Which in radians is 0 and pi, which is an answer in quadrant 1 or 2. And that really has to do with our all students take calculus, because inverse sines and inverse tangents, if you're taking an inverse sine of a positive, you're going to get an answer in quadrant 1. But if you take an inverse sine of a negative, the only quadrants that signs are negative is 3 and 4, and the calculator chooses 4. The same with tangent. And cosines are positive in 1 and 4, so it only picks one of those two quadrants to be positive. And since it's negative in 2 and 3, it only picks one of those quadrants to give you an answer in. So we call those the principal values. So what we're going to do is we're going to talk about rewriting equations for their inverses. And in order to do example 1, I kind of want to refer you back to something you probably did in Algebra 2. So like if you had an equation like this, x minus 2 squared plus 3. And we asked you to find the equation of the inverse of this. What you would do is you would switch x and y, and you would solve this new equation for y. So you would subtract 3, and then you would square root the other side, and then you would add 2. And then this would be the equation of the inverse, and we would denote that in this notation. That's not f to the negative first power, that's f inverse. So now, if I come back up here, and I want to find the equation of the inverse of arctan 1/2 x, which is the same thing as inverse tan of 1/2 x in our notation that modern textbooks use. You would start the problem by switching x and y, and then you would solve the equation for y. Now, how will we solve this for y? First, we have to get rid of inverse tan, and the inverse is tangent. And then we would get rid of the 1/2 by multiplying the other side by 2. And this would be the equation of the inverse. In example 2, we're going to use what we know about trigonometric functions and their inverses to evaluate expressions. So I want to evaluate the arc sine of -1/2, but I'm going to start this problem off by rewriting it as something we know. So we want to find the inverse sine of -1/2. This is the same thing as saying the sine of some angle is -1/2. Now, although you could plug this into your calculator, and your calculator is going to give you the principal value, and if you're in degree mode, your calculator will spit out that the answer is -30 degrees. But we don't want to do in degrees, we want to do in radians. What would -30 degrees be in radians? It would be -pi/6. And so that's the answer we're going to use, is the one that's in radian mode. All right, let's do this again. Whenever you're finding an inverse trig function, they're asking for an angle. So if you want to be in degree mode, you have to change pi/2 to be in degrees. Well, pi/2 is the same as 90 degrees. So if your calculator's in degree mode, then you want to do the inverse tangent of the sine of 90. Now the calculator doesn't order of operations. And in order of operations, what do we do first? We do what's inside the parentheses. So the sine of 90 degrees is 1. And then it's going to do the inverse tangent of 1. And that's the same as saying the tangent of what angle is equal to 1? Well, in our coordinate plane or the unit circle, the angle that'll give us an angle of 1, or if you do inverse tangent of 1 in degree mode, it'll give you 45 degrees. And in radians, 45 degrees is pi/4. For a problem like C, we're going to do this using order of operations, so we're going to do it in parts. Order of operations says, look at what's inside the parentheses first. Okay, so what's inside the parentheses, we're going to do part by part. This is inverse tangent of the square root of 3. So if you're in degree mode in your calculator and you do the square root of 3, you're going to get 60 degrees, which is pi/3. And then the arc sine of square root of 3/2, which is this inverse sine of square root of 3/2. The calculator is also going to spit out 60 degrees, which is pi/3. So we want to do the cosine of pi/3 minus pi/3. Well, pi/3 minus pi/3 is 0. So really we're just doing the cosine of 0, which is 1. The last thing we need to do for this section, problem D, we're going to do the tangent of the inverse tangent of square root of 3 plus pi/3. Well, the first thing we want to do is we want to evaluate the inverse tangent of pi/3. So if you do that in your calculator, it's going to give you 60 degrees, which is pi/3. Then by order of operations, we're going to add pi/3 plus pi/3, which is 2 pi/3. Well, if it helps you to change that into degrees, you change 2 pi/3 into degrees by multiplying by 180 over pi. 360/3 is 120 degrees. So really what we're doing is the tangent of 120 degrees. Well, if you do the hand trick, 120 degrees has a reference angle of 60. So you're going to pull in this finger, and you're going to flip your hand over, and you're going to be left with a square root of 3/1. So the answer is square root of 3. Then you have to ask yourself, I should have done this. All students take calculus. Is the answer positive or negative? If you're in quadrant 2, which is where 120 degrees is, and it's negative, so it should be negative square root of 3/2. And that's all we're going to look at from section 6-8 on trigonometric inverses and their graphs. We skipped their graphs and just looked at the inverses as they are applied to the graphing calculator.